Hello everyone, welcome back to my channel. So in continuation of my previous video on linear regression, now let's see what are different types of linear regression and let's see how does a simple linear regression works. So today our focus is what are different types of linear regression techniques and what is simple linear regression and how does it works. So let's start. So there are two different types of linear regression techniques, simple and multiple. In simple linear regression technique, we have one input variable or the predictor variable that is x, and we use this variable to predict our output variable or our dependent variable that is y. Whereas in multiple linear regression technique, we use multiple predictors or multiple input values, let's say from x1 to x5, to predict a single dependent or output variable that is y. So this is the difference between simple and multiple linear regression techniques. Now let's see what is simple linear regression technique. Simple linear regression technique, as we have just discussed, that it is the linear relationship between exactly one dependent variable and one independent variable. So let's see this with an example. Let's take an example of ice cream sales prediction. In this, we are predicting the number of units sold of ice cream with respect to the temperature. So let's analyze this. We can see that with the rise in temperature, the number of ice cream units sold has increased. At 28 degrees of temperature, the number of ice cream sold were 10, whereas at beyond 39-degree temperature, the number of ice cream sold were more than 70. So this gives us a linear relationship between the temperature and the number of units of ice cream sold, and this relationship is increasing. That is, with the increase in temperature of input variable, the number of ice cream sold, that is output variable, is also increasing. So it is having a positive linear relationship. Whereas in this example, we are determining the lifespan of a person based on the number of cigarettes consumed per day. So let's say if a person consumes 3 cigarettes per day, the lifespan is 80. And if the person consumes more than 12 cigarettes per day, the lifespan is 30. So this is the number of lifespan years that has been decreasing based on the increase of cigarettes consumed per day by a particular customer. So we can see that with the increase in the input variable or the cigarettes per day consumption, the lifespan of the person decreases, that is the output variable. So it is having an inverse relationship. So this is also a linear relationship. Linear relationship can be a direct relationship or it can be an inverse relationship. So by now you are familiar with the equation of linear regression. If not, you can check out my previous video. The link has been attached to it. So the linear regression is represented by the equation of a line, that is y is equal to c plus mx. So the equation of regression line is f of x is equal to beta naught plus beta 1 x, where f of x is a predictor variable, beta naught is the intercept just like value of c, and beta 1 is the slope of the variable of x-axis just like the slope of m of a line. So based on this, we know that the basic reason to find linear regression or to apply linear regression is to get the best fit line of the model. So that this red line is depicting the best fit line, and this is showing that this line covers all the data points or maximum number of data points in our data set. So the question is, how do we find this best fit line? Do we find it just by random, or we do have to make hit and trial methods to find this best fit line? So let's find out. So the best fit line is a basic problem in linear regression. So how do we determine the best fit line? By estimating the coefficients. What are the coefficients? Beta naught and beta 1, that is the intercept and slope, right? Or do we need something else? So let's see. So best fit line is measured with the help of a method that is called as least squared, which is having the minimum residual. So let's see what is residual first. So residuals are the error which is computed using the actual value minus the predicted value. So if we find out how do we find out predicted value, we find out predicted value with the help of a linear regression equation, which is y cap is equal to beta naught, that is a coefficient, and beta 1, beta naught was our intercept and beta 1 was the slope of the line, right? So based on this computed value, we find out the residual. So let's say we have a example of weights of a person, and this blue line is representing the average weight of a person, that is 75 kg. So based on the actual data set, this is the predicted value now, and based on the actual data set, let's say persons 1 weight 79 kg, person 2 weighs 77 kg, person 3 weighs 73 kg and person 4 weighs 71 kg. So if we calculate the actual value minus the predicted value, we get a residual of plus 4, plus 2, minus 2 and minus 4. So if we compute the sum of all these residuals, right, that is plus 4, plus 2, minus 2 and minus 4, we get a sum as 0. So do you think that if we have a sum of residuals as 0, we will be able to find out the best fit line? No. So what method we came to know? We find out the squares of the residual and then we summed it. So in squaring of a residual, what do? We do 4 square, which is 16. Then we do 2 square, which is 4. Then the square of minus 2 is again plus 4. And again the square of minus 4 is plus 16. So this gives us a value of equal to 40. So this is the sum of residuals of first model based on some value of beta naught and beta 1. So let's say we call this as model 1. So model 1 has sum of residuals, we call it as RSS. So RSS's value is 40 for this particular model. And similarly, we find out different values of coefficients of beta naught and beta 1, and so on. We can calculate till different values. Let's say we compute it using 10 models, and out of these 10 models, the model which is having the least value of sum of residuals RSS, sum of square of residual value, we find that model is the best fit line of that particular model. So, in this has been explained with the help of another example based on the sales of a TV units. So, this is the actual sales of TV unit that has been taken place. This is the predicted sales. This is the residual, that is actual minus predicted value, and then we find out the square of the residual values. So, based on the square of residual values or for different coefficients of beta naught and beta 1, we can find out different values of RSS. Let's say we find out three models, and based on three models, model 1 has RSS value of 170, model 2 has RSS value of 149, and model 3 has RSS value of 168. So in this, RSS value with the red line is 149, which is the lowest value. So we say that this red line is the best fit line for this particular example. So this is a way how do we compute or how do we find the best fit line for simple linear regression model. So in next video we will see how does multiple linear regression works. If you have any question related to simple linear regression or the best fit line, do comment me in the comment section. For more such interesting videos, if you have not subscribed my channel, please do subscribe my channel, and thank you for listening. Thank you all.